So you're working on the questions to try on page 3, and I want you to do a tree diagram, which obviously there's probably not enough room, but you can squish it over there if you really want to, and then the fundamental counting principle to determine how many different outfits there are. What's the key thing in order to use the fundamental counting principle? We have to have one of each item, right, in order to use it. And here they want one. It would be weird if they put double socks on, but who knows? You know. Choices. So we're at example 2 on page 2. So here it says, a school cafeteria offers sandwiches made with fillings. So here's the fillings, that's one type. And they're ham, salami, cheese, or egg. Then we have on white, whole wheat, or rye bread. I should have squiggled this bread, because it's not actually a kind. How many different sandwiches can be made using only one filling and one type of bread? So the moment it's one of each, we know we can use the fundamental counting principle, correct? And how many parts are there to the sandwich? 2. Some may say it's a crappy sandwich, but if someone just likes meat, this is a fantastic sandwich. It may be like, hey, can I have 2 options? You know what I'm saying? I'd be like, can I have some vegetables on this thing? But you know, what else? All right. It's also a very dry sandwich. It's just meat and bread. There's not even like mayo or something. All right. Be up my kid's alley, but if it was just cheese. Okay. So we have part 1. We're going to call this the filling. We have part 2, which is the bread. We know we can use the fundamental counting principle because there are 2 parts to make the whole sandwich, and we're only choosing one item of each part. Correct? So these questions aren't hard if you can spot them as a fundamental counting principle. They're hard if you sit and stare at them and go, ugh, I don't know what to do with it. Okay? So how many fillings are there? 4. They're also hard if you like miss egg or something. Some people do that in like 3. It's the saddest day. So there are 4. And then bread there is 3. Some people miss the white because it goes on white and 3. Now, do we need the filling and bread, or the filling or bread to make a sandwich? That's even worse sandwich. Just the bread or the meat, or just be holding egg in your hands. Just, you know, weird. So is it or and? At the very least, and. Let's put some bread with the egg, and it's not just holding it in your hand. Okay, so if it's and, we what? Multiply, because and add sound the same, but they're too similar. So there's 12 different types of sandwiches. Okay, this one, you have a Math 30 quiz, contains 8 multiple choice questions. So how many parts are there to this test? There's 8, right? So it actually is a part. There's parts to a whole. It's not as obvious, right? So there are 8 parts to this test. So we go 1, 2, 3, 4, 5, 6, 7, 8. This will be number 1, number 2, number 3, number 4. Number 5, number 6, number 7, number 8. So we know that much. Then it says each question has 4 choices, A, B, C, or D. How many different sets of answers are possible? So A, B, C, or D, you have to choose one of them, right, in order to be a correct answer. So how many options do we have for A? There's 4 for A. Nice try. Number 1. I don't know what I was saying. What about number 2? 4. Number 3. Number 4. Number 5. Number 6. Number 7. Number 8. And then some people will leave it like that. What did I tell you? You have to remember to put the dots, right? All those dots, or else this is a really large number. It is 44,444,444. That's large. We don't want that. That's not the answer. So you have to make sure we put dots. Now, the next thing that's scary is people tell me it's 4 times 8. It is not 4 times 8. We have failed you if that's where you're at. It's not 4 times 8 because that would be 32. And by the third 4, we're already bigger than that, right? So it's not 4 times 8. It's 4 to the what? 4 to the power of 8, yeah. Which is
65,536.
536?
Yeah. That's my calculation.
Nope, you're good. I just didn't know if I was hearing you right or not. So how could they make this question a little bit harder? They could say, Mrs. Lepp has a test. She has an answer key. She has it sitting in front of her face. It's 8 questions. She tips over her coffee. It spills on the last 6. How many different answer keys are possible? Sorry, I should be more aggressive. It spills on the last 6 and completely washes out all the chances of you seeing the answers. There's nothing left for you. Nothing. Except for number 1 and 2, obviously. Those didn't wash away. How would the question change? Yeah.
So maybe the test has 6 parts instead of 8.
Yes. You could keep 8 technically, but the first 2 blanks would have how many options? Only 1 in each, right? So you can either make it a 6-parter and do 4, 4, 4, 4, 4, so 4 to the power of 6, or you can make it an 8-part test, and you'd have 1 option because you'd see the answer, it's still there. 1 option, see the answer, it's still there, then 4, 4, 4, 4, 4, right? So they can restrict it that way. All right. Like the answer key starts on fire. Mrs. Lepp stops the fire before number 1 and 2 are wiped out from life. You know, that'd be a little more aggressive. A lightning bolt comes through the window, hits Mrs. Lepp. You know, it hits Mrs. Lepp. I shouldn't have stopped there. It does not hit Mrs. Lepp. It hits Mrs. Lepp's answer key. It vanishes, but 1 and 2 stay. How did that even happen? Like 1 and 2 somehow survived the debacle. All right, we haven't had really anything with restrictions yet, but the key thing is that when you have restrictions, you have to deal with the restrictions first. So that's very important. Important that restrictions are dealt with first is key. So for example, if we were doing that and we kept all 8 pieces, we would have to do number question 1 and 2 first because we actually know what the answers are to those, and then 3 to 8 after. Okay. You know what's fun about this unit is it reminds me of how stupid I was in high school when I did this unit. So I will tell you what I did, which was stupid because it's kind of comical. I really sucked at this unit in high school, which is slightly embarrassing, but it's fine. So here you have, in how many ways can 5 different models of black cars and 4 different models of red cars be parked next to each other? Now this is the catch, is the different models. So we have black cars. They can be the exact beautiful black, same black, right? But I have like a Ford Focus sitting beside, let's say, a Ford F-150 truck. Okay, I tell you to close your eyes and cover your ears, and then I move them quietly, and I repark them in other spots. And you say, I can't tell the difference, Mrs. Lepp, they're the exact same black color. Is that true? No, they look completely different, no matter how much black perfection you have done, right? Because they're different models of cars, which means they don't look the same. If they are the same model, and I park 2 black, beautiful Ford Focuses right beside each other, they're mint and pristine, they've never seen sunlight, you can't tell the difference. There's no dings, no dents, no nothing. They're like twin, perfect, black Ford Focuses. I make you cover your eyes. I make you cover your ears. I make you not be able to tell what I'm doing. I switch the Ford Focuses to the exact same spots as the other Ford Focuses. Yeah? Can you tell the difference? No, because they're the same. So how many different ways could I arrange those 2 cars? None. One way. This way. They're here, or they're here. They look the exact same, right? But if they're different models, how many ways can I rearrange them? This way, side by side, or move them to each other's spots, side by side. So there's 2 different ways. So it does matter if it's different model or same model. You have to look for those words. All right. So here we have 5 different models of black cars, and then 4 different models of red cars, and we're parking them side by side next to each other in a parking garage. Okay? If that was the case and we stopped there and there was no restrictions, how many cars are there? 9. Okay? So don't write this, it's wrong. But say we stopped here, they're parking them in the parking garage, and then question mark. How many ways can that happen? Right? If that was the case, we'd have 9 blanks. Do not write this, it's wrong for this question. 1, 2, 3, 4, 5, 6, 7, 8, 9. This would be car parking spot 1, right? How many car options would I have? I would have 9. Because do I care what color it is? I'm just parking these 9 cars, right? It didn't say I have to have a specific car somewhere and another car somewhere. I'm just parking cars. This is done worse than if I give you restrictions, because people be like, should I put 5 there? Should I put 4 there? Stupid Crystal in high school. Okay, so I put the 9 there, and then I was like, oh, I've used them all up. They're used to, what do I think? I was stacking the cars on top of each other. Like, I look back, and I'm like, you were dumb. That's what you were. Like, you know, they say there's never a dumb, that's just dumb. It is. So what does it mean when we draw a blank? How many are we leaving here? When we put a blank, how many do we put in this position? Only 1. Remember, that's us choosing 1 from that option, right? 1 from that option. If I want to choose 2 from that option, I would have to have 2 blanks, or I'd have to use a combination, okay? If it's not a permutation. So here I would have 9 cars, but I park 1. So how many would I have left for this one? 8. Now the people who put 9 here, you just picked up all the cars and restarted over. Like, you're going to be viciously never parking all 9 cars. Like, you park 1, and you'd be like, pick it up, and then park 1, and there's nothing here, and you're like, oh crap. And you pick them all up, and then park 1, and you're like, oh, I didn't leave a car behind. So if you do 9, 9, 9, 9, 9, you're never parking the cars. Like, you're putting all 9 options, and you're picking them all back up and saying, I'm going to start here. You're viciously trying to park 9 cars and never parking 9 cars. Like, it's a bad cycle of bad things. So if I have 9 cars and I park 1, I now have 8 cars and I park 1, 7, 6, 5, 4, 3, 2, 1. Don't write this. It's not right for this question, but I want to show you something. Okay, so take out your calculators. Now, you could viciously go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2, and then times 1 if you really feel the need, or you'd be like, times my 1 is nothing. Either way, it's a lot of button pressing, correct? Now, if you can rocket count, there's this awesome button that almost makes you like, in English you'd be screaming. It's an exclamation mark. In math, it does some wonderful things. So if you can rocket count, if you can go like 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, blast off, you can use the factorial symbol. So you're not writing this down, because remember, it's not right to this question. I'm just teaching you something. So if you go 9 factorial, it'll give you the answer. Now, try it out. You're going to go the number 9, and then you're going to press math. And then you're going to arrow to the left. If you have the fancy rechargeable ones, you're going to arrow to the left twice to the PRB. If you have the not fancy rechargeable ones, you're going to arrow to the left once to PRB, and then it's number 4. Did everyone find it by my directions of not putting my calculator on the screen? And then you press enter, and it gives you the answer. Now, you should not be so trusted. You should go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 and see if we get the same answer. So, to the left, place, and number. Did everyone get it? Yeah. Keep it left. Everyone trust me now? See that it works? Oh. Okay, now that was lovely, great experience. Not correct at all for the question, but that's okay. So, what is the actual question of this one? It says, park next to each other in a parking garage. If a black car has to be first and a red car has to be last. So how many cars are we parking? Still 9, so we still do 9 blanks. That doesn't change. 1, 2, 3, 4, 5, 6, 8, 9. If you want to make sure you have multiplications, you can put them in before you even move on. Now I want to park a black car first. And I want to park a red car last. So I'm going to do those first, right? So do the restrictions first. So now instead of having 9 for the first blank, how many do I actually have for options? 5. And now forevermore, there's a car parked there. So either I have 4 black car options left or 8 total car options left. Those are all the options I have left for the next blanks, right? Okay, now I have to go to the red one because it's restricted. How many cars do I have options for this one? 4. Now how many cars have I parked? 2. So now I have 4 black cars left if they ask me anything about blacks, 3 red cars left if they ask me anything about red, or 7 cars left if they ask me anything about, I don't really care what color it is, right? So when I go to this blank over here, how many cars do I have left to park? 7. Then 6. Then whispering, you guys are whisper answering. 5, 4, 3, 2, 1, blast off. Oh, I blasted off in there. So I don't have to do something. So what I could do is, I could go 5 times 4, which is 20, times what? 7 factorial, because I have a rocket count in there, right? And then type it in. So go do that in your calculator. Yeah.
Where in order of operations does factorial come?
It's just multiplication, right? So it fits in the same spot as multiplication. So what's 20 times 7 factorial? 1,000, 1,800? 100,800? I should have these memorized because I do the same notes every year. So, but then there's summer, and then other classes, and then I don't. So there's that. Okay, we're going to talk about 4-digit numbers. 3-digit numbers, 2-digit numbers, 1-digit number, whatever it may be. How do you define a 4-digit number? People will tell me something was 4 digits. It's always comical. That's how I define things in high school all the time. I would just use the definition in the definition, and then they'd be like, you can't do that. But I just did. So there you go. 4-digit number. Okay, you tell me if this is a 4-digit number or not. Ready? I'm going to pay you in a 4-digit number. 3,765. Am I paying you in a 4-digit number? Yeah. Okay. I'm going to pay you in a 4-digit number. Ready? 0753. Is that a 4-digit number? No, you'd be like, you're being cheap. That's a 3-digit number with a 0 in front of it, Lepp. And I'd be like, wait. How about 0035? You'd be like, no, it's a 2-digit number. So what's the key thing to whenever they say a digit number? The first blank?
Like it has to be over 0.
Right.
It's 1, 2, 3 to 9.
1 to 9, yeah. And you can only fit a 1-digit number in that blank, correct? And it can't be a 0. So if they say 4-digit number, and then here it goes, Eric has been assigned the task of determining how many odd 4-digit numbers there are. He's been told the number such as 5267 is a 4-digit number, whereas 0267 is classified as a 3-digit. They will never tell you this on the diploma. They won't be like, just so you know, remember the first digit can't be 0. They won't. They'll say 4-digit number, and whenever you see 4-digit number, you have to think cannot or can't start with 0. Now, people get this messed up when they say 4-digit code. 4-digit code, can it start with a 0? Yeah, you could have the worst digit code. You could go 0000. People are breaking into your house. But you could use zeros if it's a code, correct? So it's only when it's a 4-digit number that you can't start with a 0. So don't let the code throw you. I've had people not starting with zeros, but codes can be all zeros, right? Now, how can you tell something's odd? It ends in an odd number. So many people tell me it's not divisible by 2. That's what I get, which is true. But for the blank situation, a little harder to do, right? So basically, if your number is odd, the last digit has to be odd. So like, if I go, okay, is this odd or even? 700,365,475,902. You say even, because you really don't care what I'm spouting at the beginning. You wait till I say the very last number, right? Because it only matters if it's the last digit. So we're going to do a 4-digit odd number, how many there are. So how many blanks do I need? 4. What are the restrictions on this thing? The first blank can't be 0. And the last one has to be odd. So 1, 3, 5, 7, 9. Now, it doesn't say anything about the digits not being able to repeat, so you assume they can. So the only way you know that you can't repeat digits is if it says you cannot repeat digits. If it doesn't say that, you always assume you can. So in this case, it didn't say that, so we assume we can. So I can start with my restrictions anywhere. So how many options do I have for this last blank? 1, 3, 5, 7, 9. 5, right? Now I could have picked any of those. The first blank, how many options do I have? 1, 2, 9. Why can't I put a 10 there? Because you can only leave one number, it's one blank. You can't put, that's a double-digit number, right? So 1 to 9 is actually 9. What options do I have for these two middle blanks? Yeah, 10. I have 0 to 9. Now, if you forget the multiplication symbols, it's a large number, right? If you remember the multiplication symbols, it's 4,500. Now, B is a little different. Eric is now being assigned the task of determining how many odd 4-digit numbers there are with no repeating digits. Remember I told you it's my life's goal that you guys can walk away from this unit thinking it's easy and not be like me and thinking it was ridiculously hard and cry. That's what I did. Okay, so what I found to do is if it says no repeating digits, we're going to box and hold numbers. Okay, every single time it says you cannot repeat, we're going to box and hold. We'll see what that means. So we still can't have a 0 here. And here we have 1, 3, 5, 7, 9. These are true statements. Now, I still am going to start with the back one. The back one has how many options? 5. The catch here is I can't repeat. So I'm going to box and hold one of them and pretend that I kept it there so that I can't use it in any other blanks, right? Now you could pick the 1, 3, the 5, the 7, or 9. You're just not going to rewrite it in the next one, right? That's it. And I'm lazy, so I usually pick 1 or 9 so I can use the arrow and don't have to write all the numbers out. So I'm going to box and hold the 1, but you could be a rebel and do the 5. It doesn't really matter. But when I go to the first blank now, instead of writing 1 to 9 like I did in the previous one, I'm actually writing 2 to 9 because I boxed and held the 1. So here I actually, instead of having 9 options, I have 8. And say I hold the 2. This is where people error. They'll tell me 3 to 9, and this answer has picked more than the correct one. What do I have to remember? The 0. I didn't have the 0 option for the last one. I didn't have for the last digit. I didn't have the 0 option for the first digit, so I actually haven't used them. But people forget to write them because it wasn't shown that it was held, right? So you have to remember to bring the 0 back. No joke. Worst question done in all of time because everyone forgets to bring the 0 back, and the answer will be there for you forgetting to bring the 0 back. And you see it, and it's there, and you're happy, and you circle it, but you should be sad. You just don't even know. Okay? So instead of it being 8, 7, 6, 5, it's going to be 8, 8, hold the 0, 7. That's 8 times 8 times 7 times 5.
2,240.
Now we're actually going to go ahead. We'll come back to these ones in a second. I want you to flip to the next page. To 8. Nope, that's a lie. 9. So we did odd 4 digits. We agree? We did odd 4 digits. We could just box and hold and we were done. So if I just ask you for even 4-digit numbers, that means I can repeat, correct? Because it doesn't say I can't. So I'd still go my 4 blanks. The only difference is this can't still be a 0 because of the 4-digit part. But this has to be 2, 4, 6, 8, or technically it could be 0, correct? It's the only thing that's really changed. So how many options do I have for that back blank? Still 5. And for the first blank, still 9. And then for these, I still have 10, which makes sense because once again, I'm getting 4,500. So what does that say? That says that half of the 4-digit numbers are odd and half the 4-digit numbers are even, which makes sense, right? Here's the catch. I'm going to star this one. You can do one case. You can do one case when it's odds, but when it's even, you can't do one case. So when you're done writing the answer to the previous one, put down your pen so you just pay very close attention because the way to do this question is not hard. Wrapping your head around it is a little bit. So I'm going to do it wrong. So do not copy what I'm doing. Like, don't try and sneak your pencil onto the page. I'm going to do it wrong. I'm going to do it like I did the odd. Okay? So when I did the odd, I had 0, 2, 4, 6, or 8, correct? And then 0 here, except it was 1, 3, 5, 7, 9. Okay? We did it in one case. And what did we say? We said, oh, there's 5 here, and then I held 1, correct? So let's watch this. Don't write anything. So there's 5 here. And I'm going to hold the 0. Now what options do I have for the front? 1 to 9, so I have 9. We agree? That's holding the 0. Okay? What if I held something else? 0, 2, 4, 6, 8. So say I held the 2. How many options would I have for the first blank? Only 8. Because I would have 1 and then 3 to 9. Correct? What if I held the 4? I would have 8. What if I held the 6? I would have 8. What if I held the 8? I would have 8. So if I pick the 2, 4, 6, or 8, my front number is still the same, correct? But if I pick the 0, I actually have 9 options. Do you see that? Because the 0 doesn't take an option away because this one can't be 0 anyways. So you have to do 2 cases when it's even. When it was odd, I didn't have to, because if I picked the 1, the 3, the 5, the 7, or the 9, I always had 8 options for the front. It was like this one. In this case, I have to do 2 cases. I have to do if I pick a 0, because my number at the front is going to be a 9, or 2, 4, 6, 8, because my number at the front is going to be actually only 8 options. So you have to split it into 2 cases, because depending on what number you pick at the back, it changes the number at the front. Okay? But odd didn't do that. 1, 3, 5, 7, or 9 all gave you an 8 at the front, so we could do it in one full case. Does that make sense? And when we do cases, we have to add them. Good question, Sarah. Okay. So, case 1, case 2, we're going to say we can either do this case or this case. So what are we going to do to the 2 cases once we figure them out? Add them. So whenever you have numerous cases, you do not multiply. Trust me, you need to know these rules because the diploma questions are always correct answer, first 3 common mistake answers. So if you don't know if it's a perm or a com, they're going to have all that perms and com answers, right? If I know that your error is going to be, do I add the cases or multiply the cases, what am I going to do? I'm going to give answers to adding them, and I'm going to give answers to the multiplying of them, right? So cases, you add them because you have this case or this case or this case. You don't have this case and this case because then you'd have 2 4-digit numbers. And did I ask you for 2? No, I asked you for 1. All right, so let's go through and do our cases. So we'd have case 1, where we end in a 0. Here we can't have a 0, but we'd end in a 0. Or, plus sign, case 2, where we end in the 2, 4, 6, 3. Let's do case 1 first. So I end in a 0. Here I have 1 to 9 as my options. I'll hold my 0. Remember, box it. If you can't repeat, you always box. Box and hold, box and hold, box and hold. Then you won't try and use that number again. 1 to 9, I have 9 options. Box the 9. Then I have, or box the 1, whatever you want to do. 1 to 8. Can I bring back the 0? What did I do over here? I held it already. It's used up. So I can't bring it back. So 1 to 8, I have 8 options. Hold the 8. 1 to 7, I have 7 options. Multiply. Then let's do the other one. Say I hold the 8. Here I can't have a 0, so I have 1 to 7 and 9. So I have 8 options. To my sheer laziness, I'm going to hold the 9, so I don't have to write 1 to 7 on the next one. What do I have to remember to do on this blank, though? Add that 0 back in because I never used it. The previous example I did. I held it, right? Here, I didn't use it, so I put a 0 down here. Lots of people try not to write the letters down, numbers on the bottom, because they want to be lazy. You will definitely have a bigger chance of making oopsies without the numbers on these ones. So I actually have 8 options. People will pick 7. Hold the 0, and then I have 1 to 7, which is 7. When you do that, what do you get? 9 times 8 times 7 plus 8 times 8 times 7 times 4. 2280. What did you get? I was trying to hear through your whisper.
Oh, 2,296.
Nice. I heard the first two digits and then it went all faint. Because you weren't trying to let me hear, but I was really trying to hear. See how this is? Okay, we're going to go back page. What you got? Yeah. What if I just wanted you to arrange 6 books on a shelf? Or 7 books on a shelf? Arrange means it's a permutation, because order matters. If you're arranging 6 books on a shelf, how many blanks would you have? 6. It's just like arranging 9 cars in a parking lot, correct? How many options of books would you have for the first one? 6. Then 5, because you leave a book. 4, 3, 2, 1. Right? I think stuff like that. Okay. So we're back down to here. We're going to skip example 6 because it's fishy. I don't feel like dealing with it on a fishy Friday. Okay? It's not written like a diploma question. It's kind of like you don't know if you can dump it. Like, so it'll be like a letter at the beginning and 2 letters at the end, but it doesn't really specify that the beginning letter doesn't affect the back 2, and these 2 can't repeat. It's a fishy word. So we're not going to do with it because no, they would never appear anywhere because it's not consistent enough. Okay, we're on a map. This is a hardcore map, as you can tell. There's no towns along the way. This is just a very distinct map at which we curve drive to these places. Seems very realistic. I can see where we're liking this map. So James wants to drive from Pitland to St. Luke's, P to S. How many different routes from Pitland to St. Luke's? So let's pass through Q first. How many different parts are there to that driving trip if I wanted to stop? There's 2, right? There's P to Q and Q to S. There's 2 different parts to this trip. So I can go 2 blanks. Here's 1 blank, here's 1 blank. And I really hope we don't have to specify that you're taking one of those paths. Like you're not going to like go P to Q, Q back to P, then P to Q, then like that is not a route that anyone would choose. And if they do, I feel sad for them. Okay? So we're picking one route out of each of them. That's why we have blanks, right? And we can use the fundamental counting principle because we're picking one route from each of those parts. So how many parts do I have from P to Q that I could choose from? 2. And how many from Q to S? 3. Do I have to take P to Q and Q to S to get me to S? Or could I, like, I don't know, fly through time and bypass P to Q and miraculously get to Q to S? No, I can't. I have to take from P to Q and Q to S somehow to get there. So I'm going to multiply. So there's 6 paths. If your brain falls out of your head, you could always just count the 6 paths. Like 1, 2, 3, 4, 5, 6, right? So if you forget, you could always just count them. Now we're going to go from P to S through R. So there's still 2 paths we can take. We need to take both of them. We have how many options here? 3. How many options here on this little path? 1. So I get 3. So now is my answer 18 or 9? 9. Why?
Because it's either you go to top or the bottom.
Right. You're not going to do both. Like that's the weirdest path. Once again, you're just like you're going to go there and then you're going to drive home and then try the other one. Like that would be if you ended them. So you either take these paths, which are 6, or you're going to take these paths, which are 3. That's a total of 9 paths. Correct. Okay, then we're going to flip over. Okay, here we have a telephone number allocated to subscribers in a rural area. Consists of one of the following. So it's the digits 3, 4, 5. So the digits 3, 4, 5, followed by any 3 further digits. Is there any specification on these digits? So what could they be? 0, 2, 9. Then the big word or. So what am I going to do? Add. The digit 2 followed by one of the digits 1 to 5, followed by any 3 further digits. Not the most realistic question because one is a 6-digit phone number and the other one is a 5, but whatever. Roll with it. Don't overthink it. Does it say I can't repeat or anything? So I assume that I can. So I'm not going to box and hold anything, right? Because I can repeat. So, how many options for the 3? There's 1. And the 4? 1. And the 5? 0 to 9. 10, 0 to 9. 10, 0 to 9 is 10. 1 times 1 times 1 times 10 times 10 times 10 is 1,000. Plus. And we have 2, so we have 1 option. 1 to 5. I would rather you count it on your hand than get it wrong. 1, 2, 3, 4, 5. So there's 5 options. 0 to 9 is 10. And then 10. So plus 5,000. And then there's 6,000 different words. Numbers. Okay? We have one more example I just want to touch on quickly, but we were going to do way more of this after. We have the word English. Think of it as Scrabble tiles. So I have an E, I have an N, I have a G, I have an L, I have an S, I have an H. I think there's 9. I didn't know I spelled E-N-G-L-I-S-H. There we go. I think I skipped the I. There are 7 letters in English, right? Here's the Scrabble tiles. I tossed them to you. You each have an E, an N, an I, a G, an L, an I, and whatever. E-N-G-L-I-S-H. Why is it such a struggle? Because English is a struggle. I can't even spell it. All right. I'm really good at spelling. I'm not good at reading comprehension. There we go. First step is denial. I'm past that. I'm super at the minutes. Reading comprehension, we don't agree. All right. So, do they have to say you cannot repeat the letters? No, they never will. They're throwing you a word. Here's your Scrabble tiles. This is all you have. You can't be like, just wait a second. I have an extra E. Like, just pull it off yourself. No. You have an E, an N, a G, an L, an I, an S, an H. One of each. We agree? Okay. So, it says here, consider the number of distinguishable. It's always going to be distinguishable. That just means they look different. Remember how I said if it was like P-O-O-L and I swapped the O's, P-O-O-L, you'd be like, that still spells pool. That's not distinguishable, right? But then if I give you O-P-O-L, you'd be like, oh, that's different. So it's just different looking words. That's all it's saying. Words that would look different if you looked at them. Okay? So pool, swapping the O's is still pool, right? From English, and then it says, determine the number of distinguishable 4-letter arrangements. So we have to watch ourselves. Sometimes they use all the letters. Sometimes they use 4 letters. 4 letters has 4-letter words has how many parts? 4-letter words has how many parts? 4. So how many blanks are we going to have? 4. So every single one of these is going to have 4 blanks. 1, 2, 3, 4. So how many letters do I have for this first blank? How many letters are in English? 7. Then I do what? You don't have to do this, I'm going to show you. I'm assuming I can't repeat, right? We just discussed this. We have 7 letter tiles. I'm going to leave one here. I'm going to box the E. How many do I have left? 6. Then 5, then 4. Mm, 840, I believe. 42 times 20. Okay. And the next one says the first letter must be an E, so I have to deal with the first letter being an E first because I have to deal with the restrictions first. So here it has to be an E. How many options do I have? 1. Then how many do I have for this blank? 6, because I'm keeping the E here, right? It's like dropping the cars in the parking lot. You have to leave one, or else you're never parking the cars. If you don't leave the E, you're never leaving a word behind. Okay, so I have 6, then 5, then 4, which is 120. 30 times 4. Okay, vowels are vowels. A, E, I, O, U. There's no such thing as sometimes Y in math because you only put Y in when you don't have a vowel in a word, right? And we're not making real words sometimes. We're making like different looking things. That's really what we're doing. So Y's are not vowels, and the opposite of a vowel is a consonant, not a constant. A constant is math is in math is a number without a variable. A consonant in math is not a vowel. Consonant. Okay. So first and last letters have to be vowels. So we have an E, N-G-L-I, right? You can start with the first, you can start with the last, it doesn't matter, but you have to pick one of them. So I'm going to start with the first. So I have an E or an I option, which is 2. And now I'm saying I can't repeat, right? So I have to box and hold. Every single time it's a word, I box and hold. I'm going to box and hold the I. So what do I have left for this one? Just the E, which is 1. Then what do I have left for these two? I've used up how many letters? 2, so I have 5 and 4. So it's 40. D, most people will get once I show how to do it. You'll get it right every single time after that, but you won't think about it. It says the word must contain a G. So does it say where the G needs to be? So the G could be in the first blank, or second blank, or third, or 4. So there's 4 cases, right? So the G could be here, or here, or here, or here. So we're going to get one option here. We box the G. How many do I have for here? 6, 5, 4, which is 120. Then I'm going to get 1 here, then 6, 5, 4, which is 120. What are we seeing here? You're actually going to get 120 every single time, right? You're just moving the G around. So instead of showing 4 cases, what could you do? 120 times 4 different spots where it could be. Either way, you get the same answer. So there's going to be questions I want you to try. Remember I told you the questions to try, the answers follow right after it, I think 2 pages later. Okay? So you should have done one already, I saw you did it. This one here, how many arrangements of books side by side on a shelf? 6 books side by side on a shelf, that should be quick. It should not be 6, 6, 6, 6, 6. You're never parking you're not parking books. Yeah, not parking books, that's what everyone does. So make sure you leave a book behind. Okay? This one. The score at the end of a Flames game is 6 and 3. How many different options could there be throughout? So if people go 6 times 3, which is 18, which is wrong. That's what they're saying. 18 is wrong. Because how many different scores are there when the Flames have a score of 6? What does the game start at? 0-0. So when the Flames are actually at a score of 6, how many different options do they have? 7. Because you have 0 to 6 and you have 0 to 3. So you'd have 7 and you'd have 4, not 6 and 3 to fill in the blanks, right? Your first blank would be how many options you have for the Flames scoring. Well, 0 to 6 is actually 7 options. 0, 1, 2, 3, 4, 5, 6, right? And then 0, 1, 2, 3. You'd have 4 for the second blank. Okay? Should have circled that one, sorry. This one here, you have students in a class winning prizes. This one, they win the first and the second and the third prize in one math class. So you have how many blanks? 3. First, second, and third. How many can win first? 30. How many can win second? 29, because someone won first. They can't win first, second, and third. Then 28, right? Here we have a math prize, a chemistry prize, and a physics prize. Think about your valedictorian. How many could you have for the math prize? How many could you have for the physics prize? And then that's 30. So do this, and then 5. That's good.